All right, so we've looked at vertical, we've looked at horizontal. So what I want to do is look at a situation where I have something in between. So that situation is going to be a toy airplane attached to a string and flying around in a circle. And we have one of those little toys here. We'll get going. But the first thing I want to do is to draw the free body diagram. And what I have is a string that's attached to the ceiling. So that's going to be my force due to tension. I have F sub G down, and that is pretty much it. Now, what I'm going to do here is to break this up. Now this is going to be 0.03 kilograms times 9.8. And so that is going to be 0.294 newtons. Okay. I don't know what the tension is here, but I'm going to break this up so that what I have here in the y direction is that, and in the x direction I have that. Okay, and they also give us a 65 degree here. Okay, so in any case, what I'm going to first do is just say, look, F sub G is going to equal this part right here. So F sub G is going to equal F sub Ty. And F sub Ty is the sine of 65 times F sub T. So I'm just going to say it's the sine of 65 times, you know what, I'm just going to call it tension. It's F sub T. This is F sub T. I'm just going to call it T, just to make it a little easier, okay? And so I can actually find T by just saying, okay, 0.294 equals the sine of 65 times T, and the tension in that is 0.324 newtons of tension. So there we have that. Now, how fast is it going? Well, what I'm going to do then is say that the centripetal force is this right here. That's the center-seeking force. It is the sine, no, cosine. It is the cosine of 65 times T. That's what it's being provided, is that part right there. And you're going to see that this is the case if it's a normal force for a banked curve. It's going to be that part of the banking. Okay, so we'll look at that one in the next thing. So I'm going to go mv squared over r equals the cosine of 65 times t, which is 0.324. Now the other thing I'm going to do here is to plug in, is that going to work? I don't know, we'll see what happens. I'm plugging the mass of 0.03. I don't know what that is. Now the radius I have to solve for just with trig. The distance here is 0.22, not to be confused with the force vector. This is a distance vector. So the radius right here, r equals, is going to be the cosine of 65 times 0.22, and that ends up with 0.093 meters. So don't confuse forces with the distances, but go ahead and get the radius using trig, and the angle again, and the distance for the hypotenuse. And then cosine of 65 times 0.324, we get a velocity of 0.65 meters per second. So, yeah, that's how you do that problem. All right, let's go on to the next one here. Okay, so this one is a little bit more complicated, but honestly, they all kind of go down the same path. So let me quickly show you a free body diagram here. And even though this is pretty complicated, what it's going to end up being is this relationship here, which is going to end up being V is equal to the square root of tangent of theta times r times g. All right, so that's what it all ends up being, but what's happening here? So we don't actually even need friction. If we had friction, you could put it in like that. Because if remember, if we're on a flat ground, friction is all we've got. But here, we're going to say, all right, let's just say it's completely frictionless. And if that's the case, then the normal force is going to provide all of our F sub c, our centripetal force. But let's go ahead and draw the free body diagram here. And assuming we don't have any friction, if you do have friction, I think there's an extra credit problem in there. You know what? Just add it in. You've got this, you've got this, and those are forces that you have to deal with as we're dealing with all of this. But again, I'm going to go ahead and ignore that we're going to have friction, like we just don't, there isn't friction. But you can certainly add that in to all the forces and all the things that are happening. Okay, so what ends up happening here is that we have this angle right here, and with a bunch of geometry and such, you can prove to yourself that theta is theta right there, okay, from geometry and right angles and such, okay. So we are going to have F sub n cosine of theta here, and here is going to be F sub n times the sine of theta, okay. So our F sub c is going to be provided by F sub n sine of theta. So looking at all of this, if you can't break it down to make sense of it, I mean, it probably vaguely makes sense, but realizing that the centripetal force, the center-seeking force here is F sub n sine of theta is kind of your important thing to think about. And then we start talking about F sub n equaling F sub g. Well, F sub g, as you can see from this free body diagram, F sub g is going to equal F sub n cosine of theta. So doing some substitutions, what we get is mv squared over r equals, and F sub n is going to be mg over the cosine of theta times the sine of theta, and this right here will be the tangent of theta, okay. The masses cancel, and that's that relationship right here, and we end up with this equation. So all that to say is if you are on a banked curve and you're not considering friction, you can say v is equal to the square root of tangent of theta, the angle, whatever angle this is right here, will end up being that angle, times the radius times 9.8. And you can calculate any of those. And if you actually look back at the airplane lab, this is what happens with the airplane lab as well. So one quick one we'll do is the Daytona 500 racetrack to figure out how fast they have to travel if there was no friction. But of course there's some friction too. Is we just have to plug that in. So even though the free body diagram is pretty complicated, although if you follow the free body diagram and what is equal to what, it substitution-wise makes total sense. So we're looking at about 96 miles per hour that they would have to go, which is for a race car pretty easy. And again, this is without any friction, and of course there will be some friction as well. All right, next up is Newton's law of gravitation.